Hi everybody, this is Tor Storley, and in this video I will take a look at how to work with the JSON functionality SQL Server 2016 on. The JSON model that SQL Server is providing us with is a relatively straightforward model. I'll cover this using a Azure Data Studio SQL notebook. So let's open up Azure Data Studio. I'm going to run this because it will auto prompt me for a connection. So I'm going to just run this query. And over here now, it shows me the recent connection. So the one I want to use is this Python database. So as you can see, it's sitting on my 2019 instance, and it's called Python DB. And I'm just going to connect to that one. So now this query is running and is producing this outcome. So one thing you can do, you can save it as CSV, the output. You can save as Excel. You can save as JSON. And you can save as XML. And you can, if you have numbers, you can show it as a chart. Now, there's no point of showing this text here as chart. So when I run this query, you can see it produces an array of 3 names, which you see up here. If I run it now, you can see I'm back to where I started. I can add to this query this for JSON path. And what it does is it produces this outcome now. Notice that it puts brackets, meaning it puts it inside an array. You can see those square brackets in the beginning and end there. And that means it's an array. You can add to this for JSON path. You can set without array wrapper. And what I will do is, now compare with the one cell above here. And when I run this, you can see it's removed the beginning and end bracket from the output. So that's what that without array wrapper does. You can also add a root node. In this case, I had a B and then I had an array. So it's an object B and its key, the key is B and the value is the array. I can add this root node. So when I run that, you can see the root node is data, which you can see this part. And now the rest of it is the same, and it also has the actual array here, as you can see. And another thing I did there, because this is JSON, I can just double click on it and it will open up as formatted JSON in this separate page here. I can run this and it produces this people. It has different keys, name 1, name 2. And when you look at that, it looks something like this. So that's not just similar to what we've been doing. I can actually query against the table. Notice this is the US states table. Now, if you're familiar with my SQL Server geospatial video series, I used some of these tables in that series. So I transferred them into this Python database so I can work with it. So if I run this query without the JSON clause to it, it looks something like this. So it's the 52 or so states, as you can see here. And this is the information it produces. Now, once I add this for JSON path, you can see it will generate JSON out of that. So when I open this, you can see here's the ID, the region, division, the state FP, and then it has the state name, etc. So it generates a JSON output of the states table by using this for JSON path. Now, what I can also do is go against counties. So this is the US Illinois counties, meaning this table only have the counties in Illinois. So when you run that, you'll get 102 records because that's the number of counties in Illinois. And that looks something like this. We can combine the states with the counties. So one method you can use is by basically querying all these fields from the states table like this, and then we can subselect as almost like in a field, like counties field, we can subselect the Illinois counties like this. And then we link the state. For Illinois is the state FP, it's in both tables. The state FP for Illinois is 17. So we basically link the county's state FP of 17 to the state's state FP of 17 here. And then we add a for JSON path inside here. and then we add a for JSON path on the outside for the state, and then we give it a root node like this. So when I run this, what's going to happen is it's going to produce JSON that looks like this, where every state has its state information. However, when you get to Illinois, because Illinois is the only one in that county table I showed you. So when you get here now, you can see now we're getting into Illinois, and it puts JSON key that contains an array, as you can see here, of all of these. And these are all the 102 counties in Illinois. So you can produce quite elaborate JSON outputs, as you can see here. And this is only Illinois. And when you get past Illinois here, you can see now I'm back to the New Hampshire, North Carolina, so on. So it builds this fairly complicated JSON for you just by doing something like this. We can also create something very similar by using a different technique. So if you look at this one here, I'm using the same states table, and I'm using the same county table here. But what I do is I basically write it as a regular query here. So as you can see, I'm still linking on the state FP, and I'm doing the root node as before. The only difference now is I'm nested it per field. So as you can see over here, I just leave these guys alone the way they are. But then I get to here, and I'm doing this type of technique, a dot format. And notice how I mix this up. I use text here, and I use just regular field here, as you can see. I can basically use this root as state, and then I can have the name, and then I can, within state, I can have counties, and I can have all the fields for the county. So this is slightly different, but as you can see, when I run it, it still produces a decent looking JSON output. Notice here, I still have the counties here as I did. I have a state now as a kind of lead node, and then within that state I have all this about the state, and then I have as part of that the counties here, and then I even nested. Notice I nested the latitude and longitude within this location. So when you look at the code for that, you can see state, counties, location, longitude. So you're basically building the format for the JSON by doing this. So that's quite interesting. Okay, so we just looked at the for JSON, which is basically building JSON from either tables like we just looked at, or from basically just plain text. You can generate JSON outputs. So that's what we just did. So what we want to do now, we want to look at the opposite side, where we're actually going to read from JSON and put it into a tabular form, meaning we flatten it, we put it into maybe column row format, which is this OPENJSON. So let me bring up my Azure Data Studio again. So this OPENJSON is a table value function that parses the text, and it returns objects and properties from the JSON inputs, and it brings it forth in the form of rows and columns. Now, when you run the OPENJSON by default, meaning plain vanilla one, it's going to produce three fields, if you will. The key, the value, and the type. And this type indicates what the actual value is, what type of form it takes. So 1 would be a string, 2 would be a number, 3 would be Boolean, 4 would be an array, and 5 would be an object. And of course, you can learn more about it here. And when you open that page, you can see this is OPENJSON. So let me make it a little smaller here. And you can read about it here. So that's a good place to go to learn more about OPENJSON. Let's take a look at a few examples. By the way, I have this query, this table here I created. So let me see, I can use Azure Studio here and go in maybe and look at this particular table, which is in the Python DB. We'll go to tables, and it's this JSON table here I created. So if I run a query against that, it's going to look like this. So when I open this, this is what it looks like. What this represents is a Yahoo Finance query call, meaning a web API against Yahoo Finance. And in this case, I'm just bringing one ticker symbol for AbbVie. And this is the output that web query produced. So we're going to look more in detail about this, but the actual output from that query looks like this. So you can see the chart is the top node, then there's a result tag, Then there is a key of meta. So that's the metadata. And as you can see here is all the metadata about this. If you scroll down a little bit, you can see there's a timestamp. By the way, I've tried to make this as small as possible by only bringing back for 1 week, like 5 days. Now this timestamp we'll talk more about. It's a special kind of timestamp. It's what's called a Unix timestamp, or epoch timestamp, if you will. There's also an indicators key here that has another key with an array of the close, volume, high, low, open, and there's also a separate one for adjusted close, and then it ends down here. So that's the JSON output we're working against right now. That sits in that table, this Yahoo Finance JSON table. All right, I go back to my notebook, and here what I do is I declare a JSON variable of type nvarchar max, which is very common for these kind of output to JSON outputs. You probably want a Unicode, so you want to use it nvarchar because there could be all kinds of weird stuff inside your JSON file. Then what I do is I basically query that table you just saw to get the JSON and bring it into this object. Now keep in mind, when I bring this in here, it's of type text. It's not JSON, it's not valid JSON, it's just text. Then what I do, I say select star from, and then I use this OPENJSON, meaning I'm gonna flatten it into, from JSON object into a table kind of look and feel. And there's the actual variable that holds the text version of the JSON object. There's 2 arguments for this OPENJSON. It's the actual JSON object, and then where you want to drill into. So if you look at this, it says the root is the $sign dot. The first one you saw was the chart, then there was a result. So if I go back and I look at the JSON here, there was this chart and then a result. But notice this result is an array. So it has all this stuff in it. This is the array for the result. And if you follow this line down here from the result, you can see towards the end here, there's the ending tag. So this is not an array of arrays. It's an array of objects that contains array. Like here, there's an object that has an array. However, we're looking for only one array for the result. And that's why we are setting this query to have this 0, meaning that's the first array basically we're looking for. So by doing this dot notation here, I can drill into this result. So when I run this now, you can see this is what it produces. It produces these other keys, meta, timestamp, and indicator. And if you look at it here, we can see there's this meta. So if you follow this line down at that level, you can see here's the timestamp and here's the indicators. So those again has other arrays, as you can see. This one is an object that has another key and it has an array of objects. So what we're looking at here is this is the output. So notice what it tells me. This meta here has an object. Okay, this is the object of the meta. That's of type 5. And if you remember, 5 is an object. So that makes sense. You can see these squirrely brackets and you have key value pairs. This one is an array of type 4. You can see it has the brackets here. So this timestamp, it has just this. So that's an array. So that makes sense. And that's type 4, as you can see from above here. This last one here is also an object of type 5. Okay, another thing we can do just to indicate this, what it is just use a case statement like this. So I can run this again. But in this case, I want to drill in one more level. So I want to drill into this guy here. So I want to drill into this piece, okay, for the meta. When I run this now, you can see I just have this type description. So under the metadata, you can see here's a currency, symbol, all the metadata about it. Notice this is type 1. All right, so that's the metadata. I can drill in to one of these metadatas, this valid range here, as you can see. So when I run that, it will simply list the key, value, and type, as you can see, because that's the default. And if I did a star here, you can see when I run this, I'm getting the same thing, key, value, type. So those are the 3 outputs I'm getting. So here you can see the individual value for this valid ranges, meaning when you query Yahoo Finance, these are the type of parameters you can pass in for how much data you want back. I use this 5-day one, but you could do 10 years or whatever. But of course, your payload will be much larger when you do. So anyways, that's the valid ranges. So we ran this query here, top piece here, you can see timestamp and indicators. Now, if I want to be more specific, I can actually, instead of just having SQL Server determine this for me, I can actually supply a schema with my query by using this with clause. So as you can see here, I'm explicitly setting these fields to be a certain data type. And I can control this by using this with clause after the OpenJSON. So when I run this now, it's going to produce a long row here. And you can see here's all the field names, but they contain these values. So this gives you more flexibility in controlling the output as you want it to look and the data types you want to see. So just repeating the same query again so we kind of have a visual on it. You can see here. Now what I'm going to do now is I'm going to drill into this indicators, which has this key quote, and then it's an array of objects. Okay, here's one key with an value of an array, and the same thing with volume, high, low, etc. And this is where it kind of gets a little more involved. If I query this one, you can see I'm getting two fields, the quote and the adjusted close. So there's actually two keys here, and they are arrays, as you can see, number 4. I want to drill into this quote, and as you remember here, the quote is of type array, and there's only one array. So when I click here, you can see there's the array on this first line here, and if you follow that all the way down, you can see there's the ending of the array. So that means when I point to that, I want to just pass in this array 0, because that's the first array I'm looking for. So in order to get to that data, I can simply click here. Here is the close, volume, high, low, and open. However, that's only this piece. It's not the adjusted close is a separate object. I'm not drilling in for that one here. So as you can see here, here's those all arrays. To get all this into one table format, I have to use a little trickery here. First thing I do is I get the JSON object, all the JSON. Then I'm using a common table expression. So I use this because I want to get the date time as well. And remember, the date time is not here, so I have to go higher up in the document. So as you can see here, this timestamp is not at the same level as the indicators and the quotes. So I have to manipulate a little bit of the document itself. So here what I do is I do the key and the value pair, and here I'm drilling into that timestamp. Then I have the open data, which is on the quote, first array there, open. Then I do close, low, high, and adjusted close, and then I do the volume. Then I do the query. In this case, there's an index in this document here. We can link these at the same timestamp. Let's just run it, and then I'll explain it. So let me run it. So I ran it, and this key is actually index here. So all of these different objects here uses the same index, so that's why I'm able to get them lined up on the same number here. So for example, the first timestamp is 11.4, then is 11.5, 8, 9, 10, etc. And we have this Unix timestamp here. Then you have the date time when I converted it into a timestamp. And then I get the date. So I basically artificially create these two. Then I got low, close, I get open, close, low, high, and I even go and get the adjusted close from a different level and the volume. So I piece it all together here in this query. So let's look a little closer how I did that. You can see here I'm getting the volume, and then here from adjusted close I'm getting the adjusted close. So I tap in at a different point in this JSON. Here is where I do my conversions. So Unix is basically, this Unix or epoch timestamp is assuming a starting point of 1/1/1970, and what it does is it's represented in seconds since that date. So this date time, this Unix date time here, is represented seconds since that timestamp. So to convert it here, we can use this date add function, and we pass it in this s, which is the second thing. Then we cast the date time as an int, and this is the starting point. So that's what this one does. And then I simply convert this as a date here. Same thing, but I add as date. And then, of course, I do the rest of the query. And then I left out or join everything on that key. So that's the common denominator, is that key. And I order by this Unix date time. So that's how I put together this query here to actually get this data from. So here we got the JSON functions. There's 4 of them we're going to be looking at. Those are the 4 I know about, actually, unless they changed lately. There's isJSON, which tests whether a string contains valid JSON. There's JSON value, which extracts scalar values from JSON strings. There's also a JSON Query, which basically extracts objects or array from JSON strings. And Jsonmodify, which you can delete or you can change or add to a JSON object. So to find out more about that here, you can click this link and you can look at these functions and how they work in more detail here. All right, so first function we want to test is isJSON. And so that basically will validate and see if your JSON is valid. Again, we're going to query the JSON field from that table of mine and put into a variable. And then I'm going to test and see if the JSON is actually valid. If it's a 1, that means yes. If it's 0, it means no. So when I run this, you can see I'm getting a valid JSON. So returned a 1, and I converted in this case statement. So that's how you can check and see if your JSON object is valid. Now, the next one I want to look at is this JSON value. So here I'm bringing back my query again from the counties here. So this JSON value is basically producing scalar value from JSON strings. So here I got the query that looks like this. I want to basically drill in and get some of these values back, meaning there's scalar values. It's a key value pair. So that's what I'm trying to do with this particular query here. So up here, what I do is I load this guy into this object, and then I use this JSON value, and I'm passing in the value from that OpenJSON, and I just gave it an alias as D, so I can refer to D value here. That's the first argument, and then how you want to drill in to find it, which one you'll find. For example, I want to drill in and get the D, and to find that, the ID, to find that, I have to get to this level. So on the state counties, the state, then there's the ID. So this JSON value here produces a scalar output, and you can drill in like you see here. So that's one way you can do it. Another thing is, notice this counties gives me a null, but I don't know what happened here. But keep in mind, this JSON value is scalar values. If you look at this counties here in my JSON, this is the counties. This is not a scalar value. This is an object that has scalar values within it, like this. So what happened here is, well, there's one thing you can do in this SQL Server JSON. In front of this path here, you can use the keyword strict. If you do, you put the keyword strict in and I run it again. Notice what happened now, this time, when I run it. It tells me scalar value cannot be found in the specified JSON path. Line 22, it says. So what happened here is that because this is an object of scalar values, it's not a scalar value, it gives an error here, and it's very forgiving, this JSON functionality, because it just throws a null at you, so it doesn't break the query per se. But in order to find out what the problem is, you need to put this strict in front of it. When you do that, then you get the actual reason for why it didn't work. Use this keyword strict in front of it. So that's the JSON value. The next one we want to look at is this JSON query. And keep in mind from the description above here, the JSON query extracts an object or array from a JSON string. So when you can't use this JSON value, but you need to bring like a subset of JSON information out, you should use this JSON query. So here I'm using pretty much the same query I had. We can remove the strict here. However, this time I'm fixing this county field by using this JSON query. So when I run this now, using this JSON query along with the values, you can see now I'm getting a perfectly valid output back like this because it's an object. That's what it returned by using this JSON query. So whenever you need an array or an object output in the output, you can use this JSON query. By the way, also, if you have text representation of JSON, by using this JSON query, it will convert it into an actual JSON object. So you don't have the text version of it, but an actual JSON. Now, the last piece I want to cover is Jsonmodify. So we're going to change the value in the string. Now you can delete and you can modify. It's the same query again as before, this piece. The only difference here is that I create another object here and I select the JSON query as counties from this one, where I drill in and get the counties themselves. And then I select this to see what it looks like. So let's just run this one first. So it looks like this. It returns the actual JSON from that county, all right? So what I want to do now is I want to modify it. And I'm going to use that same query. I'm going to load that same new object, select it so you can see it. Then I'm going to modify it. So here what I'm going to do, I'm going to update this GeoID, just to bring your attention to it. This GeoID is 17067 currently. So I want to update it to 99999. But then I also want to add a name to it, and I'm going to do it like this. So let's see what happens. So I'll query before and after. So let's run this. And this is before. So it has the original content like this. And this is after. Notice I added this piece and I updated this piece. Now you could delete too. Let's get rid of this one. 067. This one. And I'm going to basically just make it. I wonder if I can write the word null in here. All right, let's try that and see what happens. So by doing that null there, it removed the whole thing. So there you can see you can update, which I did there. You can append, which I did here. And you can delete, which I did when I made it a null in the update over here. So here it is existing, and here it's not. Okay, so that wraps up my presentation. There might be a few other things that I didn't cover, but by using the documentation, you should be able to figure that out. So I hope this helps. I hope this was interesting enough for you, and I look forward to see you again soon. Thank you.